Okay, we are recording. Today I'm going to continue with the preliminaries, with the review. Last time we talked about properties of absolute value. Okay, and now I want to talk about how to solve equations and inequalities involving the absolute value. Again, this is going to be standard. We will keep using these inequalities and equations in the course, so it is good to set it up in the beginning. If you have absolute value of x equal to some number d, which is of course greater than or equal to 0, that means x is either d or minus d. If you have absolute value of x less than d, again d positive number, that means x is between minus d and d. Another thing, when you're writing inequality this way, so three numbers, so whenever you're writing a less than b less than c, it means a must be less than c. Okay, so we don't write, usually we write, say x is between 2 and 5, right? It means x is a number which is greater than 2, less than 5, but we never write like this. If you mean, okay, if you mean x greater than 5 or x is less than 2, this is possible, then you write it this way: x is greater than 5 or x is less than 2. If x is greater than 5 and less than 2, of course it is not possible, it's the empty set. All right, okay, so that's aside. What else? Of course, instead of less than, you may have less than or equal to. Then you have less than or equal to here. What else? If you have x greater than d, again, d is a positive number. Now, this means either x is less than minus d or x is greater than d. So maybe in interval notation, I should also give you each one in interval notation. Let me erase this aside. Okay, so x is d or minus d. Of course, it is not an interval, so we write it in the set notation. Between minus d and d, that's the open interval from minus d to d. This is the closed interval from minus d to d. This is from minus infinity to minus d, union. Since you say or, you take the union of d infinity in the interval notation. And similarly, for greater than or equal to, then you put less than or equal to, greater than or equal to. So in your interval, you close at minus d and d. Okay. Instead of x, you may have x minus a or some other expression in all of these inequalities. Then in the corresponding equivalent statement, you replace x with that expression, whatever it is. For example, if you're asked to solve, let's say, absolute value of 8 minus 3s equal to 9, then this means 8 minus 3s is plus or minus 9. So 3s is 8 minus or plus 9. So this is either 17 or minus 1, right? So s is either 17 over 3 or minus 1/3. So you get only two numbers. Or frequently, well, yes, frequently we may have to solve an inequality. I'm going quick because I think this is things you are already familiar with, but if I'm going too fast, just stop me and ask if you have a question. So let's say, okay, again, solve absolute value of 2 minus x over 2 less than 1/2. So using the inequality we set up above, this means 2 minus x over 2 is between minus 1/2 and plus 1/2. So if you add minus 2 everywhere, minus 5 over 2 less than minus x over 2 less than minus 3 over 2. And now to obtain x, you need to multiply by minus 2. But remember, when we multiply with a negative number, the inequality changes direction. So x is between 3 and 5. It means the solution is the open interval from 3 to 5. Same warning about when you're writing an interval. The starting point of your interval must be a number less than the end point, always. Okay, so we don't write 5, 3 as an interval. Okay. Now, another thing we are going to be working with in this course are graphs. Graphs of equations, graphs of functions, graphs of inequalities. So we need to set up our coordinate system. So we use Cartesian coordinates. So we take two copies of the number line perpendicular to each other. Again, arrows indicate the increasing direction. So on the horizontal line, numbers increase from left to right. And on the vertical line, numbers increase from down bottom to top. Okay. And the horizontal axis, we call the x-axis. The vertical axis, we call the y-axis. These are just names. You can, of course, name them anything you want. But in general, when we are working with equations and inequalities, we use x and y. But you can use any other name. These are just names. Okay. So a point, if you have a point P in the plane, okay, so we have the number lines. The intersection point of the number lines, we take it to be correspond to the value 0, both on the x-axis and on the y-axis. And then when you have a point P in the plane, you draw a perpendicular to the x-axis. It corresponds to a number on the x-axis, say number A, and you draw your perpendicular to the y-axis. y-axis, and this corresponds to a number b, and we say the coordinates of the point P are the numbers a and b. So for the point P with coordinates a, b, a is the x coordinate, b is the y coordinate. Intersection of the axis, intersection point of the axis is what we call the origin. So we denote it by O. Its coordinates are 0. My O's and zeros, I don't know how to distinguish them, but you understand which one I mean. Okay, so if you change your point, let's say you have a point P, or let's say you have a point P1 with coordinates x1, y1, and let's say you have another point P2 with coordinates x2, y2. Then when you consider moving from point P1 to point P2, we are making, in fact, two changes. We make a change in the x direction and we make a change in the y direction. So the change in the x direction, we denote by delta x, the change in x. This is x2 minus x1. Here, the direction is important. I'm talking about moving from P1 to P2. So I take x2 minus x1. And delta y, it's the change in y. So it is y2 minus y1. Of course, the way I draw it, both numbers are positive, but they may also be negative, of course. All right. And now using the, I'm always having trouble pronouncing, Pythagorean theorem, we can say that distance between the points, distance d between points P1 and P2 is a square root of delta x squared plus delta y squared. And this works even if delta x and delta y are negative. So it doesn't matter if you're trying to find the distance, it doesn't matter which point you take first and which point you take second. Okay, now graph of an equation. Now graph of an equation in or inequality or inequality in x and y is the set of points xy which satisfy the given equation or inequality. Now, the most famous one we will keep using in this course is the equality or inequality to describe a circle or a disk. So if you take, for example, examples, x squared plus y squared equals 1, this is a circle of radius 1, centered at the origin. I'm very bad in drawing, you will see. So suppose this is a circle. Okay, so this is 1, 1, minus 1. Minus 1. Okay, if instead of an equation, if you take inequality, let's say x squared plus y squared less than or equal to 4, then this is a disk of radius 2. So this is 2. The circle together with all the points inside the circle, we call it a disk. Well, I should say closed disk, because if you take x squared plus y squared less than 4, then this is an open disk. So you don't take the circle, just the inside. So it is an open disk. And if you take less than or equal to, that's a closed disk. Of course, they don't have to be centered at 0. In general, you can close disk. In general, you may have something like oh, no, that's just 1 point. You see the question? It would be impossible to display x squared plus y squared equal to 0. No, that's just 1 point, 0, 0. Okay. So we say, okay. X squared plus y squared equal to 0. That's 1 point. Only 0, 0. Of course, if you have a number, negative number, then it's empty set. There is no such point where x squared plus y squared is equal to a negative number. So in general, no, the area of the closed disk is equal to the area of the open disk because the circle itself has no area. Of course, it is more subtle than that, but generally the types of curves we are going to see in this course have 0 area. But in general, of course, you need to define what you mean by area, and you have to prove that those curves have 0 area, but take it for granted that all the curves we are going to consider here will have 0 area. Yes.
If we suppose that there is a negative number, can we display on the Argand diagram using imaginary and complex numbers?
Yes, of course, but not. But here in this course, we are going to consider only real numbers. Your friend asked, I don't know if you heard, but he says, if we take a negative number on the other side, let's say x squared plus y squared equals -1, then we can use imaginary numbers to display. But here, of course, it is possible, but in this course, we are only going to consider real numbers. Yeah, circles and disks is a vast subject. Okay, so in general, if you want to change your center or radius, you take equation like this. So we take r as a positive number, or 0, yes, okay. Then it's just 1 point if r is 0. So the center is the point AB, the radius is the number r, and you can take less than or equal to, or greater than, of course. Example 5, if you have x squared plus y squared greater than 1, this is not a disk, it doesn't have a name outside the closed disk. So everything outside the disk. We do have a name if you have something like 1 less than x squared plus y squared less than 4, a region between two circles. This is called an annulus. Area of, oh, number 5. Yes, yes. Area of number, example 5 is infinite. Isn't it x minus a squared? What did I write? Yes. So this is an annulus between two circles. Any other questions about circles and disks? Okay, another type of curve, not, okay, it's a curve, but we are going to encounter frequently, is a straight line. Given two distinct points, two distinct points, P1 different from P2 in the plane, they determine a unique line. Circle is the curve. Disk is curve together with the inside, or without the curve, just the inside, depending on closed or. So disk has an area, but circle has length, not area.
Can we say that the circle is one-dimensional and the disk is two-dimensional?
Yes, you can also say that. I wouldn't think circles and disks would be so interesting. Yes, they are interesting. And these are good questions because, yeah, it shows we need to understand what we are doing. So when you say circle, it is just the curve, circle. But when you say disk, it is the inside. Çember ve daire. Çember sadece eğri, daire alanı. Yes, çember and daire. Yes. So in the XY plane, you take points P1 and another point P2, different from P1. They determine a unique line. Okay. If the line is not vertical, then for any 2 points, on the line, the change in x divided by, I'm sorry, yes, this is also constant, but I want to take change in y divided by change in x is constant. And this constant is called the slope of the line. It is usually denoted by m. So if P1 and P2 are the points on your line, and let's say P1 has coordinates x1, y1, and P2 have coordinates x2, y2, then your slope is y2 minus y1 divided by x2 minus x1. And now if you take an arbitrary point P with coordinates xy on the line, in order for a point P with coordinates x and y to be on this line, again, this constant ratio must be the same number m. So look at the ratio from point P to point P1, for example. For a point P with coordinates xy to be on this line, we need y minus y1 divided by x minus x1 equal to m. It must be the same slope. And from here, we can write the equation as y equals m times x minus x1 plus y1. This is called the point slope form. You have the point x1, y1 and slope m. The slope may be given in the problem, or you may be given the second point P2 so that you find the slope yourself using the points P1 and P2. But in either case, when you write your equation this way, it's called the point slope form. If you multiply out with m times x plus, you're going to have some number minus mx1 plus y1. We call this number usually b. This is called the point intercept form. Because this number b is the y-intercept of your line. When you take x equals 0, you get y equals b. So the point 0b is on the line. B is the y-intercept of the line. That's why it's called the, not point, slope intercept. I'm sorry. There's no point here, slope. There is the slope. Yes, that angle, the tangent of that angle is the slope m. You can identify your line with the angle it makes with the x-axis, this angle, theta. Then tangent theta is your slope. Okay. I know this is, again, something you already know, but later when we learn derivatives, we will talk about tangent lines, finding equations of tangent lines, writing equations of tangent lines. And believe me, we see a lot of mistakes in those problems. So let me, I know it will look silly, but I'm going to write the example. Equation for the line passing through the point -2, 5 with slope 3. So y is equal to 3 times x minus -2, so x plus 2 plus 5. Or y equals 3x plus 6 plus 5, 11. So if you want to draw this line, to draw the line, we need 2 points. So the first one you can take to be the y-intercept when x equals 0, y is 11. And then the other one you can take maybe as the x-intercept. For the x-intercept, we need to take y equals 0. So x is minus 11 over 3. 11 3'e bölünce şöyle bir şey. So this is your line. And when you're finding the slope, be careful with the negative signs, because there may be some negative signs in the given coordinates, and there is the negative sign in the slope. And things to be careful about when you're finding the slope, the order in the numerator and denominator must be the same. So if you take in the numerator y2 minus y1, in the denominator, it should be x2 minus x1. But if you take in the numerator y1 minus y2, then in the denominator, you have to take x1 minus x2. So the order in the numerator and denominator must be the same, but otherwise you can do it in either order. What if your line is vertical? Vertical lines have equations like, okay, if you have a vertical line, let's say it is passing through the point x equals a, it means every point on your line have the same x coordinate. So its equation is x equals constant number a. And similarly, if you have a horizontal line, it's going to have an equation like y equals constant b. Any questions? Some general facts about lines. If two lines, say y equals m1x plus b1, and y equals m2x plus b2 are perpendicular, not if, this is if and only if. Two lines are perpendicular if and only if the product of their slope is equal to -1. You can see it yourself. If the lines are perpendicular, then you take one point on one line and another point in the other line. So you have a right triangle, and using the distances, you can use the Pythagorean theorem to see that the product of the slopes must be -1. Now, lines are parallel if and only if their slopes are the same. Now, if slopes are the same, but the intercepts are different, then the parallel lines do not intersect. Do not intersect. If M1 is different from M2, then the non-parallel lines intersect at a unique point. You have one line. If the other line is not parallel, then it has to intersect the other line at a unique point. Of course, it is possible that the two lines are the same, because you can write the equation of the line in different ways. Once you get an equation, let's say y equals mx plus b. You can write this equation in various different forms. Another standard form is to write it this way. Or more generally, ax plus by equals c. More general form for the equation of a line. So once you have an equation, you can multiply both sides of your equation with any number you want. So once you have an equation, you can multiply it with a constant c to write another equation. This is small c, this is big C. So as equations, they will be different, but they graphically, they represent the same line. So the question may ask you, for example, find intersection of, let's say, x plus y equals 1 and root 2x plus root 2y equals root 2. Of course, they are the same line. So they intersect at infinitely many points. They are what do you call identical. Çakışık doğrular mı diyoruz? Identical. So they intersect at infinitely many points. Any questions about lines?
But these are not the same line, right?
They are the same line, these two. The equations are different, but the lines themselves are the same. If you sketch the graph, they are both the same line.
So this is basically taking an equation and multiplying it with some constant.
Yes, yes.
So in which case these two lines are intercepting at the entire line, actually.
Yes, yes. So your friend says it's like taking an equation and multiplying both sides with some number. Yes, it's exactly what it is. So they intersect at every point on the line. They are the same line. I am going to take a break at 11:30. Sure. Okay, before the break, I want to talk about graphs of quadratic equations. Well, some of them. For the parabola, I'm going to spend some time. So this is, we are going to do it in the second hour. But before the parabola, any other questions on the lines? I'm going to take the most simple type. As in the case of a circle, you can take the center. I'm going to give everything centered at the origin. But as in the case of the circle, you can, instead of x, you can take x minus a. Instead of y, you can take y minus b to carry the center to any other point. So the first one are circles. I already did this, but so I will give you just the circle centered at the origin. Or you may have an ellipse, x squared over a squared plus y squared over b squared equals 1. A, b we take to be positive numbers. So if a is different from b, then it is not a circle, you get an ellipse. So if x is 0, y is b or minus b. And if y is 0, then x is minus a or a. So you have, again, my superior drawing skills. You get an ellipse.
So
Yes.
so if a equals b, it
It's a
makes a circle again,
Yeah.
because this
Yes.
time,
Yes.
let's say a equals b, then we're multiplying the sides with 1 over a.
You can say any circle is also an ellipse.
But not all ellipses are circle.
No, no.
Yep.
I'm not going to go into defining focuses. And if you notice, I'm giving you the definition in terms of equations. Of course, these are called conic sections. Of course, there are definitions which are independent of the coordinate system by means of focuses and distance to the focus and whatever. Same thing for the parabola, but I'm not going to go into that. That's analytic geometry. Yes, it is true. The name of the course is Calculus with Analytic Geometry, but not here, not in this subject. I'm not going to go into analytic geometry on ellipses and other conic sections, okay? So it is in the book. if you read the book and if you have any questions, you can ask me, but I'm not going to go into the foci, I guess the correct way of saying, plural of focus, foci of the ellipse. I know it's an interesting subject, but you should take, there is a course in the math department for math students, but you can ask to, attend the course, Analytic Geometry 115. So they study all of those in detail. Okay, now in the equation, x squared plus y squared equals r squared, if you take one of the terms with a negative sign, something like, say, x squared minus y squared, or minus x squared plus y squared, then you get what we call a hyperbola. Okay, I have to tell you this story. When I first went to the States to do my doctorate, they put me in a class, and it was my first time. Of course I know English, I can speak English, but it's hard to, pronounce the words. And with the word hyperbola, I still have problems. I don't know the correct way of pronouncing it. So I had this roommate. She was American, so she was trying to teach me, how to say it, but I could never learn this word, hyperbola. Okay. Let's say you have x squared minus y squared. If you have x squared minus y squared equals r squared, then it means x squared is equal to r squared plus y squared. So x is either greater than r or less than minus r. And if y is 0, then x is either minus r or plus r. So your hyperbola goes like this. If it is the other way, oops. If it is y squared minus x squared equals r squared, then y squared is r squared plus x squared. So the y coordinate is either greater than r or less than minus r. And if x is 0, it is either r or minus r. So your hyperbola goes like this. And then we have the parabola, but I guess we can take a break at this point. Let's take a break of 10 minutes. I pause the recording. Resume the recording, yes. Okay, any other questions? No, not graphically. I cannot show you the difference. They curve differently. Their definition is different. There is as I said, there is a definition for a parabola. Anybody remembers it? I think it's in a parabola. I think in a parabola, you have a point, a certain point where when you take a point on the parabola, the distance, not the distance is the same, but hatırlayalım. But what do you mean? The ratio of the distance of the point from the x-axis and the y-axis? No, 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 no. Because if you have a point here, let's say on the, okay, we will talk about, but first let me define the parabola. Efendim?
I believe you are referring to focus and directrix of a parabola.
Yes, yes. A parabola whose points are equidistant from a fixed point F and a fixed straight line. Oh, okay. Yes, thank you. So you take a point and you take, in this case, for example, it will be the x-axis, I guess. The distance to this point and the distance to the x-axis are the same. Yes, thank you. Yes, this is what you meant, I guess. Yes.
I believe a parabola has its own center axis, like
Yes.
a line where on that line, the entire point actually that's a symmetrical axis, you know?
That's true, but it is also true for the hyperbola. The parabola is symmetric with respect to this line through this point called the focus. Is it called the focus? The focus, and this line is called the directrix, probably. It is true that it is symmetric, but the hyperbola is also symmetric. But the thing is, on the parabola, you have this property that any point on the parabola, its distance to the focus and the directrix are the same, but on hyperbola,
There's not a point like that.
Actually, I don't think that in the parabola there is any point.
Sorry, what? I didn't understand you.
I don't think that in the higher sections of the parabola, like if the x point is 2 and the y point is 4, I mean the range to the y-axis and the x-axis are different.
Yes,
So
yes.
they are not equal to each other.
Yeah. So when you take a point on the hyperbola, the point xy on the hyperbola doesn't satisfy any equation for a parabola. So what is an equation for a parabola?
It's a quadratic formula, as far as I know.
Yeah. So parabolas, again, if you give y in terms of x, the most general form is, I said before, there is a definition of a parabola in terms of distances to a fixed point called the focus and a fixed line called the directrix. But here we are using the coordinates. So I'm going to give the definition by means of the equation in the coordinates x and y. So y coordinate is equal to some non-zero number a times x squared plus a number b times x plus a number c. A, b, c are real numbers, and the number a is not 0. So an equation like this, of course, you can interchange x and y. So you can take x equals ay squared plus by plus c. That's also a parabola, but along the x-axis. But we, depending on what you're doing, you may have to use either. Okay, so the parabola has this kind of shape. So it is a point here we are going to call the vertex. Okay, so to find the vertex of the parabola, basically we start with the basic parabola, y equals x squared. So it is a rough graph. When we are graphing, it is not exact point to point, just a rough graph, an idea, because we are going to be, in this course, we are going to be interested in the shapes of graphs, not the exact location of the points, but in the shape. So a parabola, let's say the parabola y equals x squared, it is symmetric with respect to the y-axis. Y coordinate, since it is x squared, is always greater than or equal to 0. So it doesn't have any piece for negative values of y. And for a general parabola, you can obtain from the basic parabola y equals x squared. How? So for a general parabola, we will complete it to a square. So first we factor out a. And then we try to write this as x plus b over 2a squared. And then we need to subtract b squared over 4a. So when x is equal to minus b over 2a, y is equal to c minus b squared over 4a, and that's the vertex of your parabola. And once you find the vertex, you can, once you write your parabola in this form, you can form the translation, take y equals x squared, shift it horizontally, stretch it by the number a, and shift it vertically by this number to obtain your graph. Or more simply, once you obtain the vertex, if there are any, you can find the x-intercepts. For the x-intercepts, if there are any, we need to take y equals 0. So if you take y equals 0, we have a times x plus b minus 2a squared equals b squared over 4a minus c. I know, I feel the same way about physics, because in high school, we learned physics as a bunch of formulas. We just memorized the formulas. But later when I learned mathematics, I see, oh, okay, I see, constant acceleration. So you just integrate to get velocity. Okay, so when you take y equals 0, so x plus b over 2a squared is, you divide by 1 over a. So this is where b squared minus 4ac comes from. The vertex. The vertex is the point where, okay, the parabola is along the y-axis. So the vertex is the lowest, smallest value for y. So that means since this is, okay, well, depending on a, of course, if a is negative, it means it is the largest value if your parabola looks down. But basically, a vertex is the value when this term is 0. And this term is 0 when x is minus b over 2a. This is how you get the vertex. But for the x-intercepts, we have to take y equals 0. So we need to set this equal to 0 and solve it. So x plus b over 2a is plus or minus the square root of b squared minus 4ac over 2a. So x is minus b over 2a plus or minus square root of b squared minus 4ac over 2a, or minus b plus minus square root over 2a. Of course, if this number b squared minus 4ac is less than 0, then there are no x-intercepts. If it is equal to 0, it means there is only one x-intercept, and if it is positive, we have two x-intercepts. Okay, so this is also, you can consider this to be the quadratic formula. So ax squared plus bx plus c equals 0 if and only if x is equal to this. So let me give you one simple example. Say y equals x squared minus 4x plus 3. So we write this as x minus 2 squared plus 4. To get plus 3, I need to subtract 1, right? So my vertex is 2 minus 1. Oh. And x squared, the coefficient of x squared is positive, so the parabola is going to look up. That means we are going to have two x-intercepts. You can also see this by factoring this out. How can we factor it out? X minus 1, x minus 3, right? So x-intercepts are going to be at 1 and 3. So you can draw your parabola like this. And the y-intercept, if x is 0, you can see. Oldu. Kalemim neden yazmıyor? Bir şey mi bastım ben? I'm sorry, one moment. My pen is not working. Ha? Nereden geçtim ben ona? Şu olan var mı? Bir dakika. Let me pause the recording and solve this problem.
There's no voice.
We can't hear you. Yes.
Başlattım. Haydi başlattım. Can you hear me now?
Yes.
Yes.
Okay.
Yes.
I accidentally turned off the microphone. I'm sorry. Okay. So if you take x equals 0, we see that y-intercept is 3. All right, any questions about parabolas?
Can we use differentiation method to find the vertex? Find use derivative of the equation.
Yes, but we don't know what the derivative is yet. Okay. Okay, and now I want to talk the most important subject on the preliminaries, functions. Okay, now function means you have one quantity which depends in a way of another quantity. So this dependence is defined in terms of a function. In this course, we are going to consider we will consider functions whose domain and range are subsets of real numbers. So our functions are going to be defined in some subset of real numbers, and the range, it takes values again in real numbers. So we call such a function a real valued function of real numbers. Okay. And when the function is defined by a formula, we take the domain as the set of real numbers for which the formula gives a real number. Unless stated otherwise. Sometimes a formula is given together with a certain restriction on the variable. In this case, we need to consider the given restriction, but if nothing is stated, just the formula, then we take the domain for which the formula gives you a real number. Examples. If you define your function f of x to be the function x squared, then that means you consider all real numbers whose square is again a real number, which is of course all real numbers. So here the domain we denote by d sub f is the set of all real numbers. So d sub f, domain of f.
So unless otherwise is stated, the area any function given operates on is real numbers, unless stated otherwise.
Yes. It will always be real numbers, but what I meant is I may give you that f of x is x squared for x less than or equal to -2.
So
Then-
that means operation area just narrows down to
Yes.
anything less than or equals a number 2, -2.
Yes. What kind of restrictions can we get from the formula? For example, if you have, if your formula is square root of x, in order to get the real number, you have to take x greater than or equal to 0. In this case, our domain is the interval from 0 to infinity. Or if you have something in the denominator, let's say 1 over x, for example, then since division by 0 is, if you take 0 in the denominator, it's not a real number, we have to take x different from 0. So the domain is going to be two intervals from -infinity to 0, union 0 to infinity. Of course, we can also write this way. From real numbers, we take out 0, but in this course, again, we will use the interval notation. So when you're writing down the domain, you need to write it in terms of intervals. So we are going to use this notation. Okay. Of course, sometimes we may also write the short the other way, but stick to the interval notation. Of course, you may have a square root together with the denominator, something like 1 over square root of 1 minus x squared. Because of the square root, 1 minus x squared has to be greater than or equal to 0, but since it's in the denominator, it has to be strictly greater than 0. That means x squared is less than 1, so absolute value of x is less than 1. So the domain is the open interval from -1 to 1. Don't forget that square root of x squared is absolute value of x. All right, any questions about the domain? Interval notation, the first one. If you use the first notation, if you use this notation, you will never go wrong. Okay. Because sometimes you may not read the question carefully. Sometimes you miss some words, and in the question, it may be asked to give your answer in the interval form. In that case, this answer, okay. So I should say something about how to write your solutions in the exams. It is important to write the correct thing. It is important not to write anything wrong, and it is important to write everything which is needed to answer the question. So this answer wouldn't be wrong, but if the question specifies that give your answer in the interval form, then it wouldn't be the correct answer. Okay, but if you use this notation, you will never go wrong. It would always work.
It's more precise, more full.
Yes, yes. There is another reason for that. Maybe it will become clear later, because some of the things we will talk about is going to be true only on connected, what we call connected sets, connected. And this set is not connected. It's disconnected at 0. But if you take this interval or this interval, it is connected. So that's why we work with intervals, because an interval is connected. Okay. Last part. Domain means tanım kümesi. Alt küme is a subset. Yes, sometimes I'm missing the chat. You can open your microphone and just remind me. I'm sorry, sometimes I'm missing you. The last part, what do you mean by the last part? Wesam? Last part? Do you want me to repeat anything? Okay, okay. Any other questions about the domain? Mansur. Okay.
So to clarify, we're looking at as a domain, we're considering anything that doesn't undefine, make the function undefinable. We're
Yes.
excluding those, right?
Yeah, yes, but undefined. Your friend says for the domain, we are excluding the values which makes the function undefined. Well, for 1 over x, yes, because for if you take x equals 0, 1 over 0 is not defined. But for square root of x, if you're considering complex numbers, it has quite a different meaning. You can define the square root of a negative number in terms of complex numbers. So that's why I said in the definition that the domain is the set of we take the domain as, yes, this is correct, as the set of real numbers for which the formula gives a real number. So square root of x, for the function square root of x, we don't consider negative numbers because square roots of negative numbers are complex numbers, not real. We only take positive. Yes.
This is from real numbers for the real numbers.
Yes, yes, yes.
I understood. Thanks.
As the set of real numbers for which the formula gives, again, a real number. Because we consider functions from reals to reals. Both the domain and the range. Tanım kümesi, değer kümesi. Both the domain and the range are subsets of real numbers. But things like 1 over x, of course, there is no ambiguity because x equals 0, 1 over 0, okay, maybe. Okay, in some mathematical structures, you can think of infinity as a point and maybe, but even then, 1 over 0 is not a number, any kind of number. So for 1 over x, there is no ambiguity, but in general, what I mean is when the formula gives a real number. 1 over 0 is not a number. Any other questions? Yes. Okay, I will quickly go over some basic graphs, maybe. Okay, so graphs of functions. Graphs of functions are graphs of equations. Okay, when you say y equals f of x, x is from the domain and y is from the range. Range is the values of the function. And the domain is the values of the input. The value, the number you put into the function is the domain. But once you input the number, the result is the value of the function. That's the range. Example. Okay, example, the function y equals x squared. This is your function, f of x. The domain, all real numbers, but the range, only positive numbers. You can put in any number for x, but the resulting number is always going to be a positive number. So -1 is in the domain, but it's not in the range. I hope this clarifies it.
Domain is your input. Range is going to
Yes.
be your output.
Yes. Domain is the input, range is the output. Okay, so the graph of a function is the graph of the equation y equals f of x. So, for example, y equals x squared parabola, we already know. Y equals x cubed. Now for x cubed, both the domain and the range is all real numbers. So the graph, it is not symmetric with respect to the y-axis, it is symmetric with respect to the origin. So it goes like this. Or y equals square root of x. It is defined only for positive numbers and the values are also positive and it's curved this way. So basically for, if you look at only the positive side, because some powers are only defined for positive numbers, of course you have y equals x. One. If your power is larger than 1, between 0 and 1, the curve is going to be below this line. So this is y equals x to the p. P is larger than 1. But if your power is less than 1, it is going to be this way. Positive, but less than 1. Okay. And for negative values of x, if it is defined, you can figure out similarly. Okay, if you have, say, y equals 1 over x. Now, this is not defined at x equals 0. For positive x, it is positive. For negative x, it is negative. As x gets large, 1 over x gets small. And as x gets small, 1 over x gets large. So the graph is like this. As x gets large, the values of y get small. It approaches 0. And as x gets small, as x approaches 0, the values of y gets very large. Or if you're approaching 0 from the negative side, y gets large in the negative direction. But if you have something like 1 over x squared, then it is always greater than 0, but still the same principle applies. As x gets large, y gets small, and as x gets small, y gets large. Another important function may be absolute value of x. Remember, this is x if x is greater than or equal to 0, and minus x if x is less than 0. So it is always positive. So x, y equals x when x is greater than or equal to 0, and y equals minus x if x is less than 0. It's supposed to be symmetric. So we have a corner at x equals 0. Okay, now I want to define even and odd functions. So suppose the domain of f of the function f of x is symmetric with respect to x equals 0. This means that is minus x belongs to the domain whenever x belongs to the domain. So the domain of f, if it includes some number, then it also includes its negative. Okay, so the function f is even if f of minus x is equal to f of x for all x in the domain. And f is odd if f of minus x is minus f of x, again for all x in the domain. Example, f of x equals x squared is even. F of x equals x cubed is odd. Okay. In terms of graphs, graph of an even function is symmetric with respect to the y-axis so if the point AB is in the graph, that means the point minus AB is also in the graph, or I should say on the graph. A graph of an odd function you can keep in mind for even function, you can consider the graph of x squared. For odd function, you can consider the graph of x cubed. Graph of an odd function is symmetric with respect to origin. So that means whenever the point AB is on the graph, the point minus A minus B is on the graph. Okay, I didn't talk about composition of functions. I didn't have time. So please read from the preliminaries chapter, read about the composition of functions. So homework, read about composition of functions and ask me your questions if you have any. Composition of functions. And that's all for today, if you don't have any questions.
I have a question.
Yes, go ahead.
What does symmetric with respect to origin mean?
Exactly what I wrote down. Whenever you have a point AB on the graph, the point minus A minus B is also on the graph. So if you have the symmetric point, if you have the point AB, it's symmetric with respect to the origin is the point minus A minus B. A, B, then you take minus A minus B.
Okay, I get it. Thank you.
I guess it's, so you consider the line through your point and the origin. Of course, my scaling is bad, but the symmetric point is supposed to be on the same line. If you don't have any questions, you may go.
Thank you, Miss. Have a nice day then.
Yes, you too. Trigonometric functions, I will talk about trigonometric functions when we start discussing derivatives. Yes, when we start discussing derivatives. Yes. When I say read, I mean from the book, from the textbook. Oh, let me stop the recording.